Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to determine how base values, coefficients, and constants will affect the graph of an exponential function and how to graph exponential functions. How are we learning it? Through the Graphing Exponential Functions Part 1 notes and the Graphing Exponential Functions Part 1 assignment. When can we use this information? To calculate the amount of money in a savings account, including interest. How do you know you learned it? By getting a score of 4 on the Graphing Exponential Functions Part 1 assignment. Now let's take a look at our agenda for today. We will begin by going over our learning goals and success criteria. While we do that, you'll fill out your Get It Started. After that, we'll go over the Graphing Exponential Functions Part 1 notes, and then I'll give you time to complete the Graphing Exponential Functions Part 1 assignment. At the end of the period, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to continue working on the Exponential Function Study Guide and any incomplete assignments that you may have. Let's take a look now at the Graphing Exponential Functions Part 1 notes. The notes begin with the learning goals and success criteria. Now let's take a look at exponential functions with bases less than 1. So when the base of an exponential function is less than 1, the curve will remain above the x-axis, and the curve will be the same, but the curve will go down instead of up. For example, we have y equals 1/3 to the x power times 4. So notice this is smaller than 1, and a normal curve goes up, but if we have a value here, a base number less than 1, it's going to go downward as we go from left to right. So it looks exactly the same as 3 to the x, except it's just mirrored over to the other side and going this direction. Now what if the base is negative? Well, when the base is negative, the graph will flip below the x-axis and will go down instead of up. For instance, we have y equals -3 to the x times 4. So here, it's going to flip and go downward below the x-axis. It's going to be exactly the same graph as 3 to the x, but it's just going to be down this direction. So it's going to be like it was reflected down below the x-axis. Now what if we were to add a constant? So when a constant is added to an exponential function, the graph will shift up or down, but the curve will stay the same. So if we had y equals 3 to the x times 4 plus 2, then it would look like this. So it would look exactly the same as y equals 3 to the x times 4, except we're going to slide it up 2 units. So now the line it doesn't cross is y equals 2 instead of the x-axis. Now, what if it was 3 to the x times 4 minus 2? Same thing, except now it's going to shift down and go this direction. So it's the same as 3 to the x times 4, except we're going to slide it down, and now the line it won't cross is y equals -2. Now what if we do a sum of exponents, meaning we add something to the exponent? Well, that will cause the graph to shift to the right or to the left. So for instance, we have y equals 3 to the x plus 2 times 4. So what that should look like is, notice it's the same curve, and because this is in the exponent, we're always going to go opposite. So you would think that we'd go x plus 2 means we're going to slide to the right. But because it's in the exponent, we're going to go opposite. So it becomes x minus x plus 2 becomes a shift to the left. So notice it's the same graph as 3 to the x times 4, except we slid it to the left 2 units. Now what if it was 3 to the x minus 2 times 4? Well, same thing. We're going to slide it, but this time we're going to slide it to the right 2, because we always go opposite when we talk about exponents. So we slide it to the right 2, and it becomes this graph. It should look exactly the same as 3 to the x times 4, except we're going to slide it to the right. There's a video here that shows you how to check exponential functions in Desmos, so you can go ahead and watch that video as well. Let's talk now about how we can use Desmos to check our work when dealing with exponential functions. So we'll go here to desmos.com, and we're going to click on Graphing Calculator. And it should take us to a page that looks like this. right here is where we can enter the equation for our exponential function. So let's go ahead and do that. So let's say it was y equals 2 to the x. Well, as we can see, it graphs it for us. It shows us what the curve looks like. And we can enter any equation in here. Let's say we had y equals 1/2 to the x minus 5 power. Well, now it has our new equation with our curve going down, and it is half as steep, right? And we can see that it's slid over to the right. So we can graph any equation using Desmos and check our work so that we can see exactly what the graph of the line should look like. So that's how you can use Desmos to check your work when dealing with exponential functions. Let's take a look now at the Graphing Exponential Functions Part 1 assignment. Our assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. It says, what is the standard form for exponential functions? Well, we know that standard form is not y equals mx plus b because that's linear, so that one's out. We're told that it had some form of a to the x times b or a times b to the x, something like that. Well, here's b to the x, but there is no a value, so we know that's not it. This one has a plus a, which we know is not the standard form. So the standard form is a times b to the x. We continue to scroll down. It says, what happens to the graph of an exponential function if you add a constant to it, meaning you add a c value? So we're going to look for that answer. It says we should have a shift up or down, which would be this one here where it says the y-intercept of the graph will shift and raise or lower the graph. So that's our answer. So we'll continue to answer each of these questions until we get to the end. Once we get to the end, we'll go ahead and click Next. This will take us to our Before You Go. Fill out your Before You Go and then submit your work on Google Classroom.